Okay, back to talking about functions. So I was just saying that if you ask a question, if you ask me a question, is the sky blue? And I say yes, no. What are you going to believe? So every question in math has to have one answer. Okay, one unique answer. Otherwise, if I say, answer 1, yes, answer 2, no, this would be an example of a non-function. A question goes in and you get 2 different answers. This is the reason why you think about kids if they have a temper tantrum, right? And you led up to that temper tantrum, didn't you? Because you said no, and then you said no, and then they wore you down, and then finally you say yes. So that's dysfunctional as well, right? Okay, a set containing ordered pairs defines a function of x if and only if 2 ordered pairs in that set have the same x coordinate. In other words, every input maps to exactly one output, okay? So for every x value, x cannot be a cheater. The same x value cannot go out with another y value. All right, so and by the way, we read this as f of x. This is called function notation right here. Function notation. And it's really just a replacement for y. So people have to get used to this f of x. We read it f of x. It's not f times x. It just means that y is a function of x. So we say y is a function of x for the function defined y equals f of x. X is the independent variable, also known as the input. So what we're putting into the machine. Y is the dependent variable, known as the output. Why is x independent? Well, you can decide whatever x value you want. You can remember when we were doing table of values for graphing linear equations back in Math 60? You could keep putting in different x values, and you get to decide what they are. That's independent. What happens is we get a y value back that depended on x, okay? So f is the function name. The domain is all possible inputs or x values. And the range is all possible y values, the outputs. Okay, determine whether or not each of the following represents a function. State the domain and the range. The set of ordered pairs in the form of vending machine buttons and products. Okay? So if you put, if you go to the vending machine, because the machine hopefully it's functioning, right? You put in, what do you put in? D3, right? Could be an example. And what would pop out if you punch in D3? Cheetos, okay? You know the machine. No, I'm just kidding. You know that number, but Cheetos, not, Cheetos and Doritos. Hopefully the machine is not spitting out multiple things. Actually, this is a funny story. It happened really in Math 60 one time. One woman, she was trying to get a Diet Coke. And so instead it was giving her Coke. And she didn't even put any more money in it, but she was just pushing the button, and out were coming all these Cokes. Pretty soon she comes into the classroom with like a whole handful of Cokes. The machine was broken. It wasn't functioning right? Okay, so the set of ordered pairs. So what would be the domain in this case? The domain would be all the buttons, right, on the machine. What would be the range or the output? What would come out of the machine? Yeah, chips or candy or food or some vending item. All vending, actually not some, all vending items. All the items that you put the money in, that's your input, you push the button, out comes the vending items. Okay, the set of ordered pairs in this form. Now, you don't know these chickens, right? But imagine that you had a flock of chickens. You have 5 chickens. Each chicken lays a different color egg, but Hazel produces light brown eggs. Yvonne also produces light brown eggs. Georgia, dark brown, Emma, white eggs, and Isabella produces green eggs. So if you tell, I'm making it up. Okay. Now, a chicken only produces one color of egg. So is this a function, meaning just because Yvonne and Hazel both produce light brown eggs, you still know it's still one kind of color for every chicken. So would that be a function? And by the way, we didn't say, yes, this is a function back here. This would be a function. Yes, this is a function. Okay. It's a function. And what would be our domain and what would be our range for the chicken example? Chicken is the domain. Good. Chicken is the domain. And the color egg they produce would be the range. Now, what if I randomly went into my fridge and picked out a color of egg? Would I know which chicken produced that egg? Why not? Oh, Hazel and Yvonne produce the same color egg. So if I find a light brown egg, I have no way of determining which chicken produced it. So would that be considered a function? So if we're listing it in this order, this would be our domain as the egg color, and our chicken name would be the range. But this would be not a function since we can't decide who made light brown eggs. Okay, now let's look at this one when it comes to numbers. Each input has to have only one output. So what are the x values or the domain? 1, 2, 3. What is the range here, the y values?